Hi. We will now quickly cover the input and output streams in C++. This is what we will be learning in this chapter. Introduction to Input-Output Streams in C++. C++ uses streams, or data flow, to perform input and output operations. The stream is an object, or a built-in, ready-to-use functionality, that extracts data units from input devices for internal storage, or inserts data units from internal storage onto the output devices. It is the header file iostream.h that contains necessary objects to execute input-output streaming operations in C++. The file iostream.h is in turn part of the C++ standard library which was earlier briefed in Chapter 4. The C++ standard library, or CSL, is part of the C++ ISO standard and is a collection of header files containing pre-built classes and functions that are reusable as objects. The library files in CSL include the utilities library, strings library, numerics library, input or output library, file system library, etc. We will now look into the family of class templates and supporting functions that are provided by the C++ Input-Output Standard Library for implementing its stream-based input-output capabilities. First one is the standard output stream, cout. By default, the standard output device of a C++ program is the monitor or display screen. The cout statement makes it possible to print data contents onto the display screen. Cout is used along with the less than sign, called insertion operator. The less than operator inserts data from RHS into the stream on LHS and can be used more than once in a single statement to create a stream of data flow. Let's look at a few examples. You have already used them in most of our programs. Cout good morning, it prints good morning onto the screen. Cout 120, it prints number 120 on screen. Cout x, it prints the value of x on screen. Inserting a new line. In C++, a new line can be inserted in two ways. \n. It's the new line character. \n is a character that is streamed with cout, either in single quotes or in double quotes. \n in single quotes occupies 1 byte, and \n in double quotes occupies 2 bytes. Next we have the endl, which is an output manipulator. Endl is a manipulator that doesn't occupy any space. Note that \n in single quotes is a single character, and so occupies 1 byte, while the \n in double quotes is an array with two values \n in single quotes, and the \0 in single quotes, and hence it occupies 2 bytes. \0 signifies null character or the end of array. Take a look at the following example statements. On first line we have cout, insert first line with the \n character. On second line we have cout, insert second line. Then insert endl, insert third line. And here is the output. Note that on some compilers, the endl will not work with the std::cout scope resolution command. In such cases, declare the statement, using namespace std, before main function, and then, use the cout object. Next is the standard input stream in C++. The cin command. The standard input device is usually the keyboard. Input from the keyboard is stored in memory location using the cin stream, followed by greater than symbol, or the extraction operator. For example, int age. cin age. Here, an input value from the keyboard is inserted into the variable named age. Cin command processes input from the keyboard after the return or enter key is pressed. So data flow is from the left to the right-hand side. You can also use cin to request multiple data input of similar or different data types in one stream. See this statement. cin extract from A, extract from B. Here, variables A and B can both be integers, or A can be an integer, B a float, and so on. Input functionality for both A and B are done by a single cin stream in this statement. The C++ manipulators. Manipulators are special stream functions that change the format of input or output data. Manipulators are used along with insertion and extraction operators and are defined in the header file, iomanip. Let's take a look at few of the C++ manipulators. First one is the endl statement, which we have already used many times. It's an output manipulator that generates the carriage return or enter key or the new line. Second is the setbase function. It is an output manipulator that converts a number to its octal, hexadecimal, or decimal equivalents. Just reminding that we use the decimal number system by default. Base argument 16, or also the function hex, converts decimal or octal format of a number to its hexadecimal format. Base argument 8, or the function oct, converts decimal or hexadecimal numbers to its octal format. Base argument 10, or function dec, converts octal or hexadecimal number to its decimal format. We will write a program to implement these manipulators. Program 12. Get a number. Display its octal, hexadecimal formats using setbase function, and also using the oct, hex, dec functions. So here we go. We write the program code. I then save it as 12.cpp. Since this program is going to use the output manipulators, on line 2 I have declared the statement, #include iomanip. On line 7, I have declared integer variable a. A memory location is reserved with name a, for integer values. On line 9, is the comment line with a remark that I am going to use the setbase function. On line 10, it prompts the user to enter a number. I enter 10 on the screen, and it's stored in the memory location A. On line 11, we see out a message stream. On the output screen, the system first prints, octal value of 10 is. Then the manipulator, setbase of 8, is inserted into the cout stream. What it does is, the system temporarily changes the number system from decimal to octal system. Remember that, by default, we use the decimal number format with the 10 digits, 0, 1, 2, 3, up to 9. So now, the default decimal system used by the computer system is changed to the octal system. Next, the value of variable a is passed to the output stream. This value from memory location a is processed by the octal system and printed onto the output screen. Finally, this cout stream executes the endl command, which takes screen cursor to next line on the display screen. Just to note, the value in variable a is the decimal number 10. Can you guess what will be printed if I now ask to see out the value of variable a? It will be 12. Because the number format has been set as octal, and 12 is the octal equivalent of decimal number 10 stored in variable a. On line 12 we are going to display the hexadecimal equivalent of decimal 10. So in the cout stream, I first reset the number system back to decimal with the setbase 10 command. Then the value of a, that is decimal 10, is printed in this cout stream. So now we have printed onto screen this message, hexadecimal value of 10 is. We next have to print the hexadecimal format of decimal number 10. Hence I insert the setbase 16 command. This resets the decimal system to hexadecimal. Next, in the cout stream, I insert variable a. So now, the value of variable a gets processed by the setbase number system as hexadecimal. And then, the result is printed onto the output screen as the small lettered a. Remember that, hexadecimal equivalent of 10 is small a, of 11 is small b, 12 is small c, 13 is small d, 14 is small e, and 15 is small f. On line 15, we are prompted to enter another number. This time, I enter the number 15. On line 16, we are going to use the dec, oct, and hex functions, which are equivalents of setbase 10, setbase 8, and setbase 16 functions that we just executed. Try to figure out the code by yourself. We get the octal equivalent of 15 printed, and then the hexadecimal equivalent of 15 is printed.